What is up, Geo Metro Ninjas? We are coming back to you live talking about another quadrilateral. This time, however, our quadrilateral is not a parallelogram. So remember, we talked about parallelograms. We talked about rectangles. We talked about rhombi. We talked about squares. Our next quadrilateral is a trapezoid. Okay. A trapezoid is a quadrilateral in which one pair of opposite sides are parallel. Since that one pair of opposite sides are parallel, our consecutive angles that are along the parallel lines are still going to be supplementary because it's following our same side interior rule. So when we look at number one, okay, we can find D and B using our supplementary relationship. So we know that A plus D is 180 degrees. They are inside the parallel lines, both on the same side of the transversal, which in this case is side AD. So we substitute 82. Subtract 82, so the measure of angle D is 98. We can do the same thing to find B. B and C are on the same side of the side BC, so the same side of the transversal, inside of our parallel lines. Remember, these arrowheads are signifying what's parallel. So the measure of C plus the measure of B is 180. Substitute what we know, which is angle C, and then subtract 108 from both sides, and we end up with 72. Now notice, these are not congruent relationships on the opposite sides of our quadrilateral. This is simply a supplementary relationship, and we can do the same thing with algebra. Okay? These two are on the same side inside, so that's our same side interior. So 13x plus 2 plus 12x plus 3 is 180. Combine like terms, 25x plus 5. Subtract 5 from both sides. 25x is 175. And then we divide both sides by 25. Well, there are 7 quarters in $1.75. The next thing we're talking about trapezoids is our median of a trapezoid. The median of a trapezoid is a segment that joins the legs, just like our isosceles or right triangles that we learned. The legs are kind of the sides. That joins at the midpoint, which means it's going to be half. You can see that each one of these now is cut in half. They're not necessarily congruent to one another, but they are congruent if they're on the same side. The median itself is half the sum of the bases. So this would be base 1 up top, and this would be base 2. But in reality, because this is a plus, it does not matter who you assign to be base 1 or who you assign to be base 2. So we're going to start with number 3. In trapezoid, A, B, C, D, E, F is a median. So we know that this is a median because they told us so. AD is 12, BC is 30. Find the length of that median. All right, so we know EF is our median, and it is half the sum of base 1 plus base 2 over 2. So EF is 30 plus 12 over 2. Combine like terms in that numerator, so 42. And of course, 42 divided by 2 is 21. They can also give us the median and ask us to work backwards. Okay, so this time we don't know one of the bases, so we take our median, 15, equals base 1 plus unknown base over 2. And this is where we can either cross multiply, which we did with our similarity, or you can multiply by 2. So 30 is 8 plus x. Subtract 8 from both sides. So x is 22. Now I know Some of you are sitting in the back. Coach, can't we just look at it and then figure it out on our own without having to go through all those steps? Somebody said, well, all we're doing is multiplying by 2 and then subtracting the other base. That's exactly what I just did. I multiplied by 2 and then subtracted 8. We take it easy. We take it through the basic steps because when the problems get tougher, if we're used to doing it the right way without taking shortcuts, we'll be more successful in the future. Our last trapezoid is an isosceles trapezoid. Now, you should recognize that word isosceles. Isosceles is where we saw an isosceles triangle. It looked kind of like this guy. In an isosceles triangle, we knew the sides were congruent, which meant our base angles were congruent. Well, guess what happens? Because this is an isosceles triangle, our sides are congruent, which means our base angles are congruent. Also, because it's going to be following the same angle pattern, our diagonals are also congruent. So the bases themselves, so these guys up top are not congruent. Obviously, you can look at them and see it, but our legs form a congruent relationship. That's on the outside. And our diagonals form a congruent relationship on the inside. And then 2 sets of congruent angles. Congruent top base angles, because technically that's still a base, so it's still a base angle, and congruent bottom base angles. So all of that stuff is true for an isosceles trapezoid, and as you can imagine, with all of that being true, they're going to spring some pretty fun algebra on us. So let's get it tackled. Okay, it tells me that ABCD is isosceles. If it does not tell us it's isosceles, we cannot assume isosceles, but we could prove if we needed to. It says angle ADC is 42, so that's this whole angle down here is 42. Because it's isosceles, we know ADC is the same as BCD. Okay, and look at that. They said BCD is 3x minus 6. Because this is an isosceles trapezoid, our base angles are congruent. So the measure of ADC is equal to the measure of BDC. This is only true for our isosceles trapezoid. So make sure they tell you, hey, that thing is isosceles. Okay, so we substitute what we know. 42 is 3x minus 6. Add 6 to both sides to get 48. And then divide both sides by 3. And we figure out that x is 16. Number 7, QRST is an isosceles trapezoid. We need to know that, okay? QT is the length 18x plus 5. RS is 21x minus 16. They told us this was isosceles, which means our legs are congruent. Since my legs are congruent, we can set them equal to one another. We know QT is equal to RS, even though QT is definitely better than racetrack. Okay, 18x plus 5, 21x minus 16. But racetrack, I can be bought if you need to throw me some free stuff. Okay, variable on both sides. We're going to move variable first. So 5 is 3x minus 16. Now that we've got our variable on one side, we're going to go ahead and add that constant. 16 plus 5 is 21. And then we're going to divide both sides by 3. So we figure out that x is 7. It wanted the length of QT, so we just take that value of x and substitute it in. 18 times 7 plus 5. And I could have substituted it into either side. Mathematically, they look the same difficulty. Can't do it in my head, so I had to grab the old calculator. And we get 131. And just for funsies, I can multiply it into the other side to make sure that it comes out to also be 120. All right, so BCDA is isosceles. Important that it tells us that because that unlocks all of our isosceles properties. BC is 7x plus 6, and this is what I was talking about earlier. AD is x minus 2. EF is 5x minus 3. So before, when it was just numbers, absolutely, we can figure out how to do it in our head. But if we did not practice setting up our formula, we would not know that our midpoint is equal to the sum, so 7x plus 7 plus x minus 2 of our bases over 2. So this is exactly what I was talking about earlier. Yes, I believe that you guys can figure it out when it's just numbers. But when we practice with the numbers where we can, yep, that's right, in our head, we can also verify what we're doing mathematically on paper. It makes this one a little easier for us. I'm going to go ahead and multiply both sides by 2 and combine like terms. So we get 2 times 5x plus 3 is 8x plus 4. I took that little bit of time to make sure that this distribution happened. So that's why I wrote that step out. Because I've seen students lose math along the way. Now we've got a variable on both sides. So we're going to subtract that 8 first. Subtract 8x from both sides. Did I mess something up? Oh, that's a minus 3. Good catch, guys. Good catch. That's why I got y'all around for me. That's what I'm talking about. Now, the reason I knew I messed something up, okay, little learning opportunity. This number right here was about to create a negative on this side. And then negatives are okay. Negatives aren't a big deal. However, when I plugged that negative into our side, it would have created a negative side length, which is a no-no. Sometimes the math don't math, but sometimes you can verify the math is mathing. So we add 6 to both sides, so 2x is 10. And we figure out that x is 5. Okay. One more question. It tells me, hey, isosceles trapezoid. Okay, the measure of angle KAT, that's this guy up here, is 5x minus 1. And then ATR is 4x plus 23. Since this is an isosceles trapezoid, my base angles are in fact congruent. So we can say that CAT is equal to ATR. So 5x minus 1 is 4x plus 23. Variable on both sides, so we move that variable first. So x minus 1 is 23. And then we're going to add 1 to figure out that x is 24. But it wanted the angle measure of KRT, so that's this guy down here. Okay. So what I'm going to do is I'm going to substitute that 24 up here to figure out what this angle is. And this is where on our quiz, some of us struggled because it was a two-stepper. So we know that this guy's 119. Our trapezoids are still supplementary down the same side. So to find KRT, excuse me, we're just going to go 180 minus that top angle we found. And we know that our angle is 61 degrees. All right, guys, that completes our trapezoid lesson. I will have the completed notes posted for you. You can kind of see what needs to happen. Thank you guys for your attention. Go be great.